Let's think about this carefully. I mean, really think. An alien civilization, let's say they exist, okay? Somewhere out there in the galaxy. Now, if they've got the technology to come here, they've obviously got to solve some very serious physics problems. And physics is physics, whether you're from the Andromeda galaxy or from down the street. The laws don't change. First thing, and this is the key thing I want you to really feel, is the speed problem. You see, the nearest star to us is about 4 light years away. That's how long light takes to get here from there. Now, there are various ways you might imagine getting to another star system. You could accelerate slowly over a long time, or you could go very, very fast. But here's what's absolutely certain. If you're traveling between stars, you're doing it at a significant fraction of the speed of light. Not necessarily the speed of light itself, but we're talking about a pretty serious percentage of it. Maybe 30%, maybe 50%, maybe even higher. Now, when something's moving that fast, really moving fast through space, there's a beautiful problem you run into. You know about the solar wind? The sun's constantly throwing out particles, hydrogen mostly. Incredibly dilute, but it's there. Well, the same thing happens around other stars. And when you're traveling at relativistic speeds, that's a big fraction of light speed, you're slamming into these particles. The energy is tremendous. It's like moving through a fog, except the fog is incredibly sparse, but you're incredibly fast. You following me? Those collisions heat up the front of your spacecraft. The ionization creates what we call a plasma sheath. It's glowing. It has to glow because all those particles are being accelerated. Electrons and protons are being stripped away from atoms. They're radiating energy in the form of light, and not just any light. We're talking about X-rays, ultraviolet radiation, visible light, a whole spectrum. The hotter you're going, the shorter the wavelength of what you're emitting. So an alien ship coming in at a very high velocity is going to be shining like crazy. It's going to look like a meteor, except it's not a meteor. It's a controlled deceleration. See, this is where most people get it wrong. They think an alien ship would be trying to hide. But if it's slowing down to enter our atmosphere, it can't hide. The physics won't let it. The energy has to go somewhere. You can't just make energy disappear. The second law of thermodynamics, entropy increases. That's not a suggestion. That's the way the universe works. So if you're dissipating the kinetic energy of a massive object traveling at relativistic speeds, you're going to radiate a lot. Now, let's talk about the appearance in our sky. And I mean, really think about what we'd see. If a ship came from outside our solar system and was approaching Earth, it would first be incredibly faint. It's still far away, it's dark, it's not slowing down yet. But as it approaches our sun, as it enters the inner solar system, interesting things happen. The density of the interplanetary medium increases slightly near the sun. There's more solar wind, more particles. The radiation environment intensifies. The smart thing to do, and any civilization smart enough to cross the stars would be smart enough to do this, is to start decelerating early. You want to spread out the energy dissipation. If you've got a week to slow down instead of an hour, you're not radiating as intensely. The power is the same, roughly, but it's spread out over time. Instead of a blinding flash, you get something gradual, something that might even be mistaken for a comet at first. A fuzzy light in the sky that gets brighter over several days or weeks. But here's where it gets really interesting. That plasma sheath, that glowing ionization around the ship, it's not uniform. It can't be. The ship has structure. It has a front, a back, sides. Maybe it has radiators. Maybe it has engines. Maybe it has maneuvering thrusters. All of these create asymmetries in the plasma. And asymmetries mean the light isn't going out uniformly. You get focusing effects. You get what we call a bow shock, a wave of compressed plasma in front of the ship, like a wave on a boat. And that bow shock is very bright. So, what would we actually see? First, a point of light that gradually gets brighter. It might look greenish or blue, depending on the exact composition of what it's colliding with and the temperature of the plasma. It would move across the sky in a way that's different from any natural object we know. A meteor's trajectory is determined by gravity. It's actually a conic section, an ellipse or a parabola. An alien ship decelerating, that trajectory can be anything. It can turn, it can slow down, it can speed up again. It can do figure eights if it wants to. And here's something that I think is really beautiful about this. It's not mysterious, it's not magic, it's physics. Honest, straightforward physics. What we're looking at is the fundamental problem of how you move matter around in space against resistance. And the solution creates light. It creates this spectacular light show because you're doing one of the most energetic things you can do. You're converting kinetic energy into heat and radiation. Now, somebody might say, but Richard, why would an advanced civilization be so inefficient? Why would they be radiating all this energy? And that's a good question. That's a real question. The answer is maybe they wouldn't. Maybe they'd use some propulsion system we haven't thought of. Maybe they'd use gravitational effects we don't understand yet. Maybe they'd find a way to bend space-time itself. And if they did that, if they did something we don't understand yet, then from our perspective, they wouldn't appear to obey the rules of physics as we know them. They'd seem to do impossible things. They'd disappear from one place and appear in another without crossing the space in between. But that's the crucial thing. If they're doing something we can't explain with our understanding of physics, then maybe, just maybe, we're learning something new about physics. That's how science works. That's how we've always progressed. Someone observes something that doesn't fit the current theory, and we go back and we figure out what's wrong with the theory. Maybe there's a new phenomenon. Maybe there's a gap in our understanding that we need to fill. So, let's imagine our scenario. An alien ship appears in our sky. What do we see? Astronomers see it first, probably, on telescopes or through surveys. A point of light that's getting brighter, moving in a way that doesn't fit any catalog of known objects. Then it becomes visible to the naked eye. It's moving across the sky in ways that don't fit any rules of gravity. Or it's radiating in all these different wavelengths simultaneously. Ultraviolet, visible light, infrared. We point all our instruments at it. Spectrographs show us a composition that makes sense in terms of plasma physics, but the exact mix of elements is strange, not Earth-like, not solar-like. And here's the paranoia part. Here's where people get nervous, because we can't tell if it's hostile. We can't tell if it's peaceful. We can't tell anything except that it's real, and it's here, and it's not following the rules that we're comfortable with. The whole world is watching. Every government, every scientist, every person with access to a telescope or a radio. And we're all trying to understand what we're looking at. Are we looking at a probe, a scout, a generation ship with thousands of beings inside, an automated mining operation? We have no way to know. And that's the thing that really gets me thinking about all this, not the technical details. Those are easy enough to work out with some careful thought about physics. What gets me is the meaning. What does it mean about our place in the universe? What does it mean that there are others out there? Not because we should be afraid. I'm not one of those people who thinks aliens are automatically hostile. That's stupid thinking. But because it means we're not alone in the universe. And that means all our philosophies, all our religions, all our ideas about what we are, they have to be reconsidered. They have to be expanded. Think about the light show itself. It's almost beautiful in a way. An alien civilization trying to enter our world is creating this spectacular display of physics. They're demonstrating, whether they mean to or not, that they understand the same laws we do, that they live under the same constraints. They can't escape the speed of light. They can't escape the conservation of energy. They can't escape entropy. They have to dissipate their kinetic energy somehow. And when you do that, you create light. The universe insists on it. So here's what I want you to take away from this. If aliens showed up in our sky tomorrow, what we'd see wouldn't be magic. It would be physics. Beautiful physics, yes. Spectacular physics, sure. But physics, nonetheless. The machinery of the universe laid bare. A civilization from another world telling us, through the light they have to radiate, through the spectrum of their plasma sheath, through the trajectory of their descent, they're telling us about who they are and what they understand. We'd have to learn to read that language. We'd have to look carefully at what the sky is telling us and figure out what it means. And you know what I find really wonderful about all of this? It's that the universe is comprehensible. We can actually think about what would happen. We can take the laws we understand, Newton's laws, Maxwell's equations, thermodynamics, and apply them to a scenario that's completely outside our experience. And the laws work. They give us answers. They tell us that an alien ship would glow. They tell us it would have to slow down. They tell us we'd see it in our sky as a point of light getting brighter, moving in strange ways, radiating across multiple wavelengths. That's profound. That's the profundity of science, that we can understand things just by thinking clearly about how the universe works. The funny thing is, even the unknowns are wonderful. We don't know exactly what propulsion system they'd use. We don't know if they'd be able to manipulate physics in ways we haven't discovered yet. We don't know what they'd want, what they'd think of us, whether they'd find us interesting or insignificant. But the fact that we can ask these questions, that we can wonder about them and think them through, that's the beauty of being conscious in a universe that obeys rules. We get to discover those rules. We get to test our understanding against reality. And every time we do, we learn something new about what it means to exist. So, if you're ever out looking at the sky at night and you see something that doesn't quite fit, something that's moving in a way that seems to break the rules, don't immediately think it's aliens. Probably it's not. But also, don't dismiss it. Look at it carefully. Think about what you're seeing in terms of physics. Think about what forces might be at work, what constraints the universe is imposing on whatever that object is. Because whether it's an alien spacecraft or some natural phenomenon we don't fully understand yet, the universe is telling you something. And the best thing you can do is listen carefully and think hard about what the message might be. So how aliens would appear in our skies, not as mystery but as physics. Not as the unknowable, but as something we can actually think through and understand. And maybe that's the most profound thing of all.